Friends, we have today two of the experts in the field of power management and optimization of the power cost in any press operations or any operations as such. And Elias would be talking about maintenance excellence, in where we actually enhance the life, expectancy of a press or a printing equipment as such. So, during this COVID pandemic, we all faced certain amount of revenue loss, certain amount of circulation constraints, challenges, and the scare of infection, and so many things. Operations were really tough these days. Tougher was the controlling the cost. And one of the things we have seen with reducing activity in the plant area is our power cost. Fixed power cost remained to be the same, while variable power cost was also coming down. So we found that about 1/3 of our total cost that goes in operations goes in power, just simply paying for the power bills. So power is one of the most important factor in running an operation effectively and cost optimized way. So Dr. Kushade, today he's an expert in this area. We consulted with him also a few years back, and he will be talking about what can we do for optimizing our power bills or power management. Elias is an expert in automation and other area, and he will talk about how we, in this age where more and more R&D is coming down in terms of OEMs, they are not having enough fund into invest into R&D and developments. So we have to have our machines kind of like, in sourcing, learning, and then enhancing the machine's life cycle, so that our infrastructure we can use for much longer time. So Elias will be talking about that and making a presentation about that. So at end of their presentations, both of their presentations, we'll have QA sessions where I'll be directing the questions to both the speakers, and they will give us answers for the questions. So I'll now invite with pleasure Dr. Kushade to address our gatherings.
So thank you very much. Thank you very much for inviting me to deliver a session on energy management. So today I'll address a very important topic, not only for printing industry, but across the globe. And the topic is going to be the holistic energy and power quality management. Already stated by Snehasis that power cost is going to become a very important cost, and day by day, the energy cost in each and every country, those are increasing on a year-to-year basis. So today I'll take you through a journey, because when you talk about energy cost reduction, it needs to be journey, and I'll address all the important aspects of energy management. So today I'll talk about the holistic approach, because the conventional approach is not adequate to get the saving in a sustainable manner. So let us discuss about the energy management as a philosophy. Everyone knows that energy management, it focuses on judicious and effective use of energy, because our aim is, without compromising on requirement, we need to reduce the energy cost so that the profit will get maximized. And there are two important components as far as the energy management is concerned. One is wastage and second is loss. And only we are required to focus on waste elimination and the loss minimization. Now, what factors they drive the wastage? There are three important factors. The first factor is the use of energy more than requirement is the energy wastage. Use of energy when there is no activity, that is the idle running of the machine, is also a wastage. Third, use of energy when the energy requirement can be made by natural resources like use of daylight or natural ventilation is also wastage. So our target in printing industry needs to be, by good housekeeping practices, the waste should be eliminated to zero. And once we eliminate the waste to zero, because the waste elimination will not need any investment. So it will happen with the regular resources available with us. Second important factor comes then energy efficiency. Losses, those are going to occur in energy transmission, energy conversion. Those are going to decide what is the energy efficiency when we are using various equipment in a printing process. Now, what factor they are going to govern the energy efficiency? There are multiple factors. The first and most important factor is what is the peak efficiency of the equipment which you are selecting for to deliver a particular function. You are aware that the peak efficiency or the actual efficiency of the equipment is decided at certain operating point is one of the parameter, and that is decided by the loading. Second, you are aware that all equipments are powered through electrical energy. When electrical energy is used, the quality of power is very, very important, and then we talk about the voltage quality. Voltage quality is not going to decide only energy efficiency, but it will decide the operational behavior of the equipment as well. It will decide the life of the equipment, because electrical stresses, those are the stresses leads to accelerated aging and premature failure. Third parameter which will decide the efficiency is the physical environment. When we talk about temperature, what are the ventilating conditions as well as what are the humidity conditions. Derating is the approach to accommodate extra loss. We go for oversizing of the equipment, and derating approach is against energy efficiency. Maintenance is very key, because our maintenance philosophy needs to be governed by whether my equipment is healthy, because a healthy equipment will deliver the peak efficiency. And most important aspect in energy management is number of stages in energy conversion or transmission. You are aware whether it is a mechanical system or electrical system, many times there are 5 to 6 stages. Even single stage is energy efficient, the overall efficiency of multiple stages reduces significantly, and that's why the approach needs to be, can I eliminate the number of stages to 1 or 2, because that will not only save energy, but you are aware once we reduce the number of elements, the cost of maintenance and reliability of the system improves. Load types is another parameter. Now, when it comes to the energy management, see, energy management, it focuses with the objective of energy cost reduction. So there are multiple principles, and we are required to consider all principles in energy management program, right from energy substitution, procure energy at lowest cost, need to use energy at highest efficiency, renewable energy resources are available. You are required to use low investment technology, because many times it happens, people, they always feel that energy management program needs a big investment, reuse and recycle and fuel substitution. So what approaches we follow for energy cost reduction or saving? The best approach is the parametric optimization, because you are aware each and every printing process, it needs physical parameter and electrical parameter to deliver its required technical function. If you are required to do the best implementation of the energy management program, we need to understand what is the parametric requirement and then keep a very thin margin of safety, and that helps in multiple ways. First is, it will help to reduce the energy cost. Second, it will help to reduce the stresses. Third, it will keep our system which is going to be visible, because over parameter setting, it transfers the system from visible system to the blind system, because the machine will not give the symptom that it is not well. Better utilization of the equipment, process and equipment modifications, all these are the key approaches we are required to follow. Now, when we are doing energy management, we are required to consider key factors. Load requirement already we have studied. Number of stages we have studied. Third is, what is overall efficiency? Because efficiency of the individual equipment is important, and what is going to be the overall efficiency of a cascaded system. Electrical environment, when it comes to the power quality, you are aware the voltage quality is going to decide whether our equipment they are compatible. If they are not compatible, it will result into breakdowns, it will result into mal-operation, and everyone understand breakdown and mal-operation related issues are very costly for printing industry during the main edition, because the time during that breakdown time, the utility will keep on running in an idle fashion, and physical environment as discussed. Now, there are two approaches, those are followed. The conventional approach, which is being followed for many decades, at least in India and many other countries, it was a component optimization approach. What that approach means, you are aware any process will consist of various subsystems. Each subsystem will comprise of various equipments. So conventional approach focused on segregating or isolating the individual subcomponent and again the equipment in subcomponent, analyzing it in isolation. Analyzing in isolation is not a correct approach, because there is an interdependence of various equipment as far as the overall process is concerned. Second, in that particular approach, only 1 or 2 parameters related with equipment was studied, and that resulted into either no saving, either less saving, and in some cases it resulted into increase in energy consumption too. And that's why what approach I'm presenting today, which we have implemented at many places, is a system optimization approach. Because in system optimization approach, the overall philosophy is holistic energy management. In holistic energy management, we are going to study the complete system, and the journey starts from the process. I need to respect my process in terms of physical variable, in terms of electrical variables. I'll understand the requirement very precisely. I'll add the drops in the distribution system. I'll keep very small margin of safety to handle the uncertainties, and then I'll study each and every subsystem, each and every component or equipment, all parameters those are controlling the energy in an integrated and coordinated way with all possible energy saving measures. And once we analyze all opportunity, the best will be selected, which gives the best ROI, and that will help us to switch from the conventional journey where the energy performance or energy cost, it is a cyclic fashion. You will find we are not in position to bring down the energy cost in a sustainable manner. So this systematic approach, you will find will help us to go down from high energy cost to the next level by no investment options, then next level by retrofit, then next level by replacement of inefficient equipment. And that's why only the approach which will bring the sustainability is the holistic approach. Now, after eliminating the wastage, our total focus is going to be on energy efficiency. Now, what are the benefits? Why we need to respect energy efficiency? Because energy efficiency is going to provide us multiple benefits. The direct benefit is going to be the reduction in energy cost, reduction in maintenance cost, reduction in mean time between the failures. Because my equipment is going to deliver the required technical function at highest efficiency, it indicates the losses occurring inside the system is less. And what drives the failure is losses. What drives the failure is the stress. That will help us to improve our system reliability. It will improve the product quality. And the biggest advantage in today's scenario is the extension of life of infrastructure of the newspaper industry. The overall focus of this approach is we are required to analyze each and every equipment, whether it is operating at the peak design efficiency or nearer to that. And it happens many times that certain parameters, they may allow the equipment to drift from that point. We'll analyze those parameters. We'll identify the insignificant, that is the equipment with lower efficiency, and we are required to take the corrective action. So that is the best approach. Look at the curve where you'll find the mean time between the failure is always a concern for all manufacturing processes. If I'm going to operate my equipment at a base efficiency point, which is indicated by red dot, what you'll find, the mean time between the failure will be almost closer to zero. That's why if I want to optimize all cost, if I want to optimize the infrastructure, if I want to extend the life of equipment, if I want to improve the quality of production, reliability of the production, the only and only approach is let us operate equipment at best efficiency point. So that will going to provide multiple benefits, and that is possible with holistic energy management. As said previously, holistic management is going to evaluate all possible energy cost saving approaches or opportunities, and it will select the best one. Let us say take a case here of one pump. There were three energy conservation opportunities. One was changing the control valve, second was trimming the impeller, and third was use of VFD. You will find here all the three cases was studied in detail, and finally the VFD was providing the maximum saving. So holistic approach will allow us to select the VFD which is providing the best ROI. So our investment will go in right direction, and we are not required to do a repeated investment to achieve the saving. So coming back to the printing industry, everyone is aware there are multiple energy cost centers. The cost centers are classified into HVAC, that is heating, ventilation and air conditioning, compressed air, lighting, printing machine, but major are printing machine and HVAC and air compressor. As rightly explained, that energy used in printing industry is categorized into three categories. One is variable consumption, which is linked with production. Second is fixed unit, that whatever energy is getting consumed, that consumption is not linked with production. If there is a zero production, that much energy will get consumed. And third component is a make ready component. So if I add these make ready and fixed, you'll find the ratio is 40 to 60. And in energy management program, we are required to focus on bringing down the energy cost of each component, whether it is a variable, whether it is fixed or whether it is make ready. And then energy utilization, typically, if you look into the section wise, the press and utility, these are the two areas where the major energy is getting consumed. Now let us start discussing about the chilled water system, because in many plant where those are air conditioned plant or those need basically the air conditioning system for process, chiller and chilled water systems are one of the major energy consuming centers. And all those systems are driven by motor driven system. So here you will find in motor driven system, the key opportunity is, it is very common in industry that there are 3 stages, 4 stages in energy conversion or transmission. So how we can reduce those stages either to 1 or 2. And then energy balance of a typical pumping system is provided in a flow chart. What you will find here, as we add more stages, the overall efficiency of the energy conversion process will get reduced. So the approach is, the topmost approach what we are required to follow is parametric optimization, followed by, can I reduce the number of stages, because that will provide me a very good improvement in energy efficiency and cost reduction, and that will help me to maintain less number of components, and that will reduce my overall cost. Now I'll give the example of conventional approach and how holistic approach is going to address all those concerns. In conventional approach, at least in our country, it happened that we were using the old motors. Those are known as standard motors. And then it happened many times that people, they say that energy efficient motor, they are having higher efficiency by 4%. So without studying the load, the motor was driving the pump. So motor was isolated and people, they replaced the standard motor by energy efficient motor, even though the pump was correctly sized. I'll give an example. Here only one parameter was considered, which is the efficiency. The rest of the parameter of the motor was not considered, and its relation with pump affinity law was also not considered. Now in this case, what will happen? Let us evaluate the scenario. The standard motor is going to run a 2% slower speed compared to energy efficient motor. Means the speed of the energy efficient motor is going to be higher by 2%. Now look at the pump affinity law. The power consumed by the pump is proportional to cube of the speed. So what will happen? When the speed is increased by 2%, the power consumption will get increased by 8%. So my efficiency improvement by switching from standard motor to energy efficient motor is 4%. At the end of the day, by isolation approach, by fragmented decision making approach, I will be losing 4% additional energy. And that's why the holistic approach is required, which is going to cover study of all parameter, all subsystem, their interconnection, their interdependence, and that's why this is only the best approach. When it comes to the chilled water system, we are aware that right from basically providing the cool air to the evaporator, to the condenser, to the cooling tower, you will find there are multiple stages. There are 5 stages. And chilled water plant is very, very important in terms of printing industry, because you are aware the chilled water plant is required to run under 3 conditions. One is there is no production. Second, there is a make ready. And third, there is a production. So you will find the chilled water plant will be subjected to the different loading conditions. And in chilled water plant, the chilled water flow is decided by the loading of the chiller. And that's why chiller plant performance matrix is key as far as the overall plant performance. What is the total tonnage? What is the total kilowatt of the plant? Whether we are meeting the water requirement as per the tonnage. What is the individual chiller efficiency? What is individual chiller lift? Whether compressor they are working at the required suction and discharge temperatures. What is the heat exchangers effectiveness? And in this particular graph, you will find approach needs to be what? My each and every equipment needs to be operated at a particular loading where I'll get the lowest specific power consumption. So in case of chiller, you will find at 60% loading or 50 to 60% loading, the kilowatt per ton is very less. So we are required to focus the overall plant performance by parametric optimization, by adaptive approach, so that for every loading condition, my plant is going to deliver the expected energy efficiency. So in chilled water also, we are having a lot of opportunity for no or low investment cost saving. The water management is one. Then entering chilled water temperature set point is very, very important when we talk about the temperature set point. Eliminating the all refrigerant leaks, maintaining the design water flow rates, eliminating refrigerant leaks, remove non-condensable gases and moisture, then calibrate and maintain temperature sensors, because it happened. Temperature sensors, those are not calibrated, thermo wells are not maintained, and finally my chiller is going to work based on the sensor signal, and many times it happens that there is a energy loss. Clean and fouled and scaled evaporator, you can see the difference that if the evaporator scaling or fouling happens, or condenser fouling or scaling happens, then energy consumption increases. And you can see that after cleaning, there is a substantial reduction in the energy consumption. Optimizing the chilled water temperature is very, very important, because you'll find the energy consumed by the chiller or kilowatt per refrigeration tonnage is decided by the chilled water set point. To understand what is the temperature requirement and set precisely the chilled water temperature. So this graph you will find here, the fouling increases energy consumption, and once you clean the tube, the energy consumption of the chiller reduces significantly. Now next important area for energy consuming area is a compressor, and you are aware in print industry, compressor is required for multiple functions. One is the impression cylinder, second is required for cleaning, and third is required for certain pneumatic cylinder operations. Compressed air is highly inefficient source because 80% of the energy is converted into heat. And further, if demand assessment is not done, high pressure and low pressure headers are not separated, the receivers are not installed at the demand side, if there are leakage are happening in the network, if we are not isolating the equipment, those are not in production, then compressor system is going to create the very high energy cost implication as far as the overall system cost is concerned. And that's why we are required to look into, in totality, how I will maintain my compressor system. Pressure is very, very important, because here you will find our way of working is, if my press is in position to run at 6 bar, then over a period of time leakages increases. And what we do, we follow the painkiller approach. We'll increase the pressure. So, and that pressure increase will reduce the CFM and it will reduce the power consumption. But what is the most important aspect, as you increase the pressure, the system which was visible, which was in position to provide the symptoms, will become blind. So again, it may not work at that particular pressure. Again, we'll increase the pressure. And finally, we are converting a system, or we are compelling the system for breakdown. And that's why in compressor system or any system, selecting the parameter on a higher side is not a correct approach, considering energy efficiency, considering maintenance requirement, as well as considering the life of the equipment. Next comes leak detection and the process setting of the compressor, because the distribution system piping is a key. Here you will find how to set the pressure, because you are required to find the requirement, add the pressure drops, and then decide how much should be the band between load and unload setting, so that my compressor will operate with a minimal set point. When you are using different compressor, we are required to ensure that the modulating of the compressor needs to be done in a manner that for meeting the fluctuating air requirement, only VSD should be used. And for base load, we need to use the compressor which is going to provide the best specific power consumption. Coming back to press, you are aware press is going to contribute more than, that is between 50 to 70% consumption. And then what are the key parameters which decide the press consumption? One is the type of drive, whether it is AC or DC motor. What is mechanical transmission system? Whether it is going to be direct transmission, or whether it is going to be coupled, or whether it is going to be through the belt and pulley. What is the operational speed? We have done a lot of work and we studied that the power consumption, it depends on the speed. So we need to identify which is the speed which is going to provide us the maximum number of pages printed in one unit of energy. What is blanket? What is blanket condition? Roller setting? What is the operating procedures? What is maintenance and correct setting? Paper and ink viscosity, number of breakdowns in terms of electrical and mechanical, because breakdowns are very costly. The last point, what I would like to highlight is power quality and energy. These are the two sides of the coin. And it happens many times that we only implement energy management program ignoring the power quality aspect. So power quality is very, very important from operational point of view, from efficiency point of view, and from life point of view. And that's why while selecting the equipment, we are required to drop the specification from energy efficiency point of view as well as power quality point of view, so that equipment will be compatible. Equipment will not generate disturbances. And if we follow this approach, then we will not require to go for any kind of retrofit options. Those are costly and those are going to add the cost. So this particular slide provides the complete power quality phenomena classification, and this is required to be considered from totality, because this will provide all benefits. At the end, we did a lot of work for printing industry. Many groups, Times is one of the group where we provided them services. But twice we did audit, Dainik Bhaskar, and there are many other clients in our country. So I'll just give two cases. The case study one, where we did an audit at plant level, where the total saving was 17.83%, with investment 13.56. No investment was 4.27. This is the plant level at one press location. Total group level annual energy cost was 220 million Indian rupees, and total group level realized saving during phase 1 was 11% and phase 2 was 5%. Whatever saving we are sharing, these are the validated realized saving indicated in the financial figures. Case 2 was again plant level 18.25%, with investment 12.65%, and no investment 5.6%. And total group level annual energy cost saving was 67 million Indian rupees. So if you look at the complete database and the approach, I think holistic energy and power quality management is the way to bring sustainability in newsprint industry in terms of energy cost reduction, in terms of improving the reliability, in terms of reducing the maintenance requirement, increasing the mean time between failure, and most important is extending the life of infrastructure, because you'll be not required to replace the infrastructure if you follow the conventional way. So I think this is the best way to deal with, and everyone is requested to follow the holistic approach in the interest of the environment. So thank you very much.
Okay, Dr. Kushare, thank you so much for your holistic approach, and we really, got some information which is quite valuable for optimizing our power cost and power things. And today, when we see that in a big plant, only a particular line is running because the number of copies that you have to print tonight or the night before is substantially reduced because of the COVID pandemic. This kind of an approach, holistic approach, will really help in optimizing the power cost. So now I'll turn to Elias Martlingus to talk about how do we improve or enhance the machine life. Elias, please come in.
Thank you. So thank you for joining in to the short talk about innovative solutions that we try to use at our power plant or printing plant. I want to give you a brief overview on what we try to do to extend the life of our printing presses, and moreover to the spare parts that we use. I realized during the last few days that the conference has become a little bit more international than before. So for the ones that are that we are unknown to them, I want to give you a short overview of our printing plant and a few quick facts. We are located in Munich, southern Germany. We are one of Germany's biggest daily newspapers, and we produce about 250,000 copies per day, and we have a ink consumption of about 600 tons per year. But I have to say, during the last few months, these figures have obviously dropped a little because of the COVID situation. Our facility was built in the late 80s, but the machines were updated in 2000 to 2002, and that will be important later on. We use 6 sections of Monroe and Coleman presses and 5 Farah post-press assembly lines, and we also have an integrated automated storage. But now, when we think of products that we all consume, we buy or produce, they have a typical product life cycle. Products are developed, then brought to the market, the sales pick up, and then a saturation in the market is reached and the sales decline. The product usually gets replaced by a successor then, but these life cycles of products can be measured in years, some in months, or even days. But one thing is in common with all products, and That is that the product life gets shorter and shorter, and the frequency of replacements get higher and higher. Just think of an example like cars. In the 70s, the average duration time of a car in the market was about 10 years on average. But today, a model usually gets replaced already after 6 years. But also the variety of models have increased because all the production lines were optimized. I now think of spare parts. The spare parts for these models won't be produced for such a long time anymore. Now think of electronics. This is even more so the case there. Most of you still know that Finnish mobile phone was produced for almost 7 years. Now the average life cycle for electronic phones is 10 months. So what does that all has to do with news? Think of our business. It is probably the same or even more extreme. The supply of news started with news that were delivered weekly newspapers, and shortly after they were published every day, then even twice a day. But what happened, especially during the last few years? Now news get published maybe every hour or even more often. But think of what's the case with our printing facility. What does it mean to us? Do we replace our printing presses earlier? In our case, we try to make the most of our machines because the nature of our news industry doesn't allow us to invest more and more. The printing presses that we use, they were designed to replace after probably 15 to 20 years. But we realized that they need to live for maybe 25 years or even longer. At our company, we try to live standardized processes. And we like to think that everything is connected to one or another. I think for everybody, the goal at a production of the newspaper is the highest quality that is possible. For that, you need to know a lot about the product quality itself. You have to measure it. It's best to know everything about the material quality that you use, the paper, the inks. That's why we run a quality lab where we analyze all the material that goes into the newspaper production. But when you work on the best production of newspapers, you want to have stable processes because only a stable process is repeatable and therefore efficient. And it's probably always the case that when you observe your processes in detail, it will most likely lead you to points where improvements can be achieved. And we realized that these improvements is not only to have a very efficient fault detection, we want to add value. We want to make things better than before. And we realized that this leads us to creative ideas, to improvements and not just restorations, and more often to new technologies or creative solutions. Since we are so process management focused, we also use a whole variety of different standardized methods to investigate, detect, and evaluate failures and possible solutions. Now, I could talk endlessly about process management and different methods, how you can find out the faults of something in a printing issue, for example. Here, I just want to stress 3 major parts that are crucial. The correlations. You always need to know why things act together. The causes. You try to find the true cause of failures because often people are misled just by the symptoms. And the effects. You have to come up with solutions that really fit the need. And here I want to give you a real life example that we had at our company. We had issues because we had delays during the setup of the printing press or during plate changes. But why did we have these delays? Because the manual turning of the printing press didn't work properly. The manual turning of the plate cylinder, for example. But why was it faulty? Because often switches were worn out because circuit boards were damaged or corroded. So there were many different options that we had, but a very simple one would be exchange the circuit boards or the switches with the OEM parts. Would be a simple solution, but probably the parts would be defective within a few months and it would be very costly. The option 2 would be to remake the circuit boards so that they become more cost effective. So we designed new circuit boards and had them produced and assembled in-house. What we did is we learned in the maintenance department how to design, how to draw circuit boards. We sourced a supplier for the circuit boards itself. We sourced all the parts, the switches, the electric components, and we soldered and assembled the circuit boards in our maintenance department. So, but what is the true benefit of it? One is the benefit of improved costs. The cost of 2 OEM circuit boards equal about 24 in-house replacements. So with the cost of only 2 OEM boards, we could retrofit all existing switches with in-house replacements. But the true benefit 2 was now we know how to design, source, and build circuit boards in-house. And we adapted this knowledge and technology in many other areas in the printing facility. Now, a second example. We had issues that subscribers and customers didn't get their newspaper in time or at all, which is unacceptable. But why did it happen? Because packages were transported to the wrong delivery route or vehicle. But why? Because the labeling of the packages was inadequate, it wasn't readable for the machines. And why? Because we had issues in the electronic part of the circuit board, of the printing head, of the label printer. So very simple would be the idea of just replacing that printing head. But in this case, the printing head on that generation wasn't in production anymore. It wasn't available anymore. So the only option would have been retrofitting, switch out to a new generation, which would be very expensive. Option 2 would have been to control the lost packages with more staff, more workforce, more personnel. Doable, but not the preferred way. And option 3, to repair the existing printing head, which is difficult, but that was the approach that we took, because the part that was faulty was just a very small plastic piece that because of the time just bent, and the conductive rubber that connected a fixed part with the circuit board moved, and therefore there was no optimal electric connection. And the part that we designed was this very small plastic part. We drew it in CAD, we engineered it, and then we printed it in 3D printing in our printing facility. So this small part that only cost a few cents that we built ourselves saved us from investing in a new generation of printing heads that would have costed a 6-figure number because we had to replace all printing heads on 7 production lines. So that's why we came to the application of 3D printing. And now we use 3D printing for many applications. Here in the background, you can see the production of 3D printed masks. We use that for printing face masks during the start of COVID in March, because there was no availability of the cloth masks that everybody uses now. We printed a lot of various things for the COVID situation. Also, we had the problem that some spare parts weren't available because of production issues and sourcing issues. But mainly we use 3D printing now for the production of spare parts, because mostly we want to produce parts that are no longer available or not even available in the way they were designed to. What that means is, in this case, we used a broken part. This is a housing for an electric component, and there is no case by the manufacturer, by the OEM, that you can buy for this specific electronic device. So we use a 3D scanner. We scan the broken part, and then we produce a printable STL file, which is the common file format for 3D printing. And then we print a case. In this case, we used clear plastic because we wanted to ensure that the electronics still fit in the case. And then we mass produce the finished cases in 3D printing. And why is it crucial? Because the electric components, they are still functional, but the only way to ensure they succeed the lifetime they were designed to is that we can produce these cases that are broken. In most cases, the electronic parts of the device, they are not defective. It's only the case. In other situations, this would be another example, is that here you can see the housing of a display, and it is not sold separately by the manufacturer, by the OEM. You can only buy the whole unit, which would be a mid-four-figure number for this display. They get knocked over. You all know the production conditions in the facility. They get broken, but all the components on the electric circuit board, the display, are still fully functional. Only the case is broken. And to produce just a plastic casing would be in the region of 50 to 100 euros, whereas the whole unit would be probably around 2,000 euros. So now we developed the implementation of 3D printing and 3D scanning, and we are now trying to generate a digital 3D spare part stock. So we take parts that we have issues with sourcing because they have a very long lead time, or parts that are not available. We replicate them, we re-engineer them, we draw them in CAD so that we can either order them somewhere else, source them, or that we can print them with our own 3D printers. I hope that gave you a little idea of what you can do when you take some kind of fault and you try to investigate it and come up with some kind of creative idea and then implement technologies for something different. So back to you, Shinasis.
Thank you, Elias. It was wonderful to see that how a small printer head equipment in a few cents can actually save you a large amount of money. This is just an example, guys. This is just an example how you can take this philosophy of creating, compatible systems which will actually take your mileage to a large extent. So it was wonderful, and we would now more or less have got an idea about what we wanted to understand from both of you, and thanks very much. This is very useful to all of our audience. Now I will quickly like to get into the question and answer. And for all the participants, we will continue till we have questions. So we have no limit of timing. So I'll take the questions one after another. Most of the questions, by the way, came for the power management system, but I would like Elias also to talk about them once Dr. Kushare finishes with his answer. So both of you can participate. That would be wonderful for me. Okay, so first question, Dr. Kushare, for you. What will be the major key focus areas towards energy cost savings with printing industry in future? Is it solar, wind, or something else? It is asked by Mr. Kumar Natarajan.
It's a very good question. If you look into the energy management principles, I'll say in India, solar photovoltaic, rooftop solar photovoltaic is going to be one of the area to harness renewable energy. What kind of advantage is going to provide? You are generating energy locally and it will be used locally. So it will help to reduce the losses in the transmission and distribution system too. The other opportunities, what I'll share with you is, let us go for parametric optimization. I think if you understand, because my experience with printing industry is, somewhere we follow the painkiller approach. If machine is not working, increase the parameter setting. And we keep on increasing the parameter setting till the generating equipment achieve the highest setting, and then we start looking to why it is not working. I think harnessing energy locally and going for parametric optimization and aligning our maintenance strategy, those are efficiency driven rather than the conventional maintenance approaches. I think that will help to optimize in a big way.
Okay. So Elias, you want to say something about solar, wind, non-conventional energy? What is the future?
I would agree that is a very regional thing, how to source the energy. For example, in the part of Germany where we are situated, Bavaria mostly imports the energy from other neighboring countries. And that is a whole mix of nuclear energy, it's solar energy, it is solar energy, and it not yet really decided what will be the majority of energy source.
Okay, so wonderful. So there is an opportunity to do localized power generation by using non-conventional energy. Number two questions came from the person didn't tell his name. Can we generate electricity with the running guide rollers at the press? So it is typically Dr. Kushare and Elias, they are talking about rotating parts of the machine. As we are rotating the parts of the machine using electricity, can we generate kind of like electricity out of the rotating parts?
Please. Sorry. So I'll just explain that we need to respect the law of energy conservation, because if you are going to connect any generator to the existing rotating system, finally we are adding another component which will have its own loss. So I think we'll waste more energy, because finally the energy which will come from the source, some portion of the energy will be wasted in that device in energy conversion. So that is not the correct idea and it's not recommended.
Yeah, that's totally correct. The only chance I see here, what we are doing is you can use machine heat, that you try to move away from the machine, from the cooling system of the printing press, and you can use that heat for either heating, what we use for heating our building, or you could use that to generate electricity.
Wonderful. So linked to that, the question number 5, I would like to take to you, Elias, first. Is it possible to utilize heat recovery from UV systems? Now, a lot of the people today running UV drying, curing system for, ink on the non-porous material like glossy paper. So is it possible? UV creates a lot of heat, like 60% is the IR in the UV system.
Yeah.
A lot of heat is being created. So can you use those heats? This question is come from Mr. Nagesha Nayak.
It is true that it generates heat, and that is unwanted in to be out of a heating unit. But it's not known to me that there are any solutions that you could heat up water and anything else, generate electricity. Would be a smart idea. On the other hand, if there is a lot of radiant heat outside the heating chamber, then it would think of me that it is not a very sufficient and contained heating unit. Okay. There is losses anyway.
Dr. Kushare, what Elias has said, that if you have a lot of heat generation in UV system, that means you don't have a efficient cooling mechanism running in the UV system. So heat generation minimized at the point of heat generation where the lamp is fired, not in the ambient atmosphere. So
see, if you look into the overall system, the reality is whatever heat is exhausted to environment, it is because of the inherent characteristic of the process. Now the question here is, there are two ways of looking at it. One is how to improve so that the heat generation will be less. And second is, we can use this heat because this heat is a low grade heat. If you look into the heat, it is a low grade heat. And this heat can be used for the heating the water by using basically the heat exchanger. You are aware the hot water is required in CTP. So we can replace the electric geysers, as well as we can use this hot water in kitchens, because we need in canteen the hot water for basically preparation of the food. So I think this is the best way to use the existing heat generated by the UV system till the new efficient technology is not available.
Very, very optimistic thought process. We don't run the UV system all the time to be able to supply hot water to the kitchen, but we'll keep it in our mind. You know, something can be done to use that. But we do use closed loop heat exchanger to take the heat out of the UV lamps. So we don't have a really opportunity to take the water out or heat out to somewhere else. In the heat exchanger, with the chilled water, we exchange the heat and make it cooler. That is the things we do. Okay, another question has come, very interesting, from Arunoday Ravikante. What is the key benefits, operational and print quality of LED over UV energy systems? He's again talking about using LED system as of UV system, which is probably he's talking about non-conventional UV lamps. Conventional UV lamps are, it's like very high heat generation and lot of power consumption. LEDs normally takes 1/3 of the power or less. It does create a lot of heat as well, but it takes a lot of input power is 1/3, maybe even less today. But at the same time, energy that it creates to cure the ink has to be perfectly matched with the ink's chemistry. So there is give and take in the both system. So can we do this? Is there anything that you can do about this? Like UV system and LED system. Of course, LED would be more energy efficient.
See, when we compare the two systems, the comparison needs to be on apple-to-apple basis as far as the required performance what we expect. And if both are meeting the expected performance, then the second parameter which come into picture is the energy performance.
Okay, thank you very much. I'll take two quick questions, two more. One, for health and power savings, is it possible to introduce a cycling method? Like if everybody comes and just do a cycling type of thing, all employees, so it generates certain amount of electricity and and that generated power can be used for something. So the question, the name is not given by the question here. You can take that question up.
See here, what question he has raised, I think that is one of the approach which will help, which will keep the health of everyone, because let us do it mandatory. So that will become another part of distributed generation, where people, they will do exercise and the energy generated, it can be fed to the local distribution system. But in terms of the amount of units those will be generated, I think that energy generation will be very marginal compared to whatever energy we are consuming.
Okay. So another quick question to you, Dr. Kushare. How do you make your people trained or make them sensitized about the responsibility to take for the power savings? It came from Rainer Christian.
Yeah, I think this is one of the very good question, because the biggest challenge in energy management is what? The people involvement and people connect and people ownership. So what we did, or what we are doing in every energy management program, first we take a 30-minute training capsule where we explain people why energy management is important and how it will give benefit at individual level first. How it is going to be beneficial, because always we say energy management says opportunity. Energy management only focuses on positive approach. So we explain to the people that if you follow energy management, you will only think positive, and positive thinking, it gives all benefit. And then we tell them very small tips how to save energy at home, because the instant they will start using those practices at home, they will also continue in their workplace. So I think this is a cultural change, and in cultural change, individual need to understand how this activity is important to me first and then to my organization.
Wonderful. Last question very quickly came from Abhishek Sharma. What is the low-cost solution for hard water? Elias, can you take this one? What is the low-cost solution for hard water? I mean, of course, we need to soften it up a little bit to be able to use it in our system.
It depends on where you are. For example, in our place, we have extremely hard water, and we need to soften it up immensely. So we have more the issue of having very, very hard water. So I only know the case that you have to turn around and soften it up, which is we use osmosis to harden it up. There are many different solutions on chemical basis. It just depends on the source of water you have. We've seen that we have different type of hardnesses in our region, and we can source water depending on that.
Okay, great. Thank you so much. And before I hand it over to Ingi to close the session, I would like to thank all the participants, and special thanks to Dr. Kushare and Elias. That it was wonderful to interact with you guys, and if there is any further questions from the audience, you can continue asking the questions. WAN-IFRA will address those questions and personally mail you back and let you know the answers of your questions. Thank you for participation. Ingi, over to you.
Thank you, Mr. Roy, and thanks for a good moderation. And thank you, Dr. Kushare and Elias, for very good presentations. Your presentations were very informative, and like you say, you're changing people's mind, and it's very good. I just want to tell everybody about our meeting point now. Our sponsors have opened the virtual exhibit, so everybody go to the virtual exhibit after this, and we meet back at 2 o'clock for main telesense of Man Roland. All the best, and see you soon. Take care. Bye-bye.
Thank you all. Thank you.
Bye.